We're going to calculate the empirical and molecular formulas given certain information. Now, an empirical formula here at the top is the lowest whole number ratio of each element, each atom of each element. So down here, we actually have our answer. This is going to be some type of simple sugar. What they would do is they'd tell you two pieces of information. They would either tell you the formula weight and the empirical formula, or they would make you go find the empirical formula using the 4 steps. So in this case, they give us the empirical formula, so lowest whole number ratio, and we're going to go through these 2 steps. So the first step says divide the molecular mass, it's always going to be given, this is 180, by the empirical mass. Now the empirical mass is what we think of if the empirical formula was in fact a molecule. So we have 12 for the hydrogen, we have 1 for each of the hydrogen, 12 for the carbons, 1 for each of the hydrogen, so that's 2, and then 16 for that. So we're going to add that up and it's going to be 30. This is what the empirical mass is. If the empirical formula was 1 mole of it, it would have this. We divide that into the molecular mass or the formula weight, which will be given. And you should get a whole number out of this thing, and you're going to get 6. Well, what does that mean? It means that the empirical formula weighing 30 needs to be 6 times bigger to equal to 180. And then so we go to the second step, and the second step just says if you're going to, in fact, multiply everything, meaning all the subscripts, by that whole number. So now you're going to have C6H12O6. And that's how you do molecular formulas when you're given the empirical formula right here and given the formula weight, which you always will be. Now let's do one that's small. It only has 2 elements, but we're going to go through these 4 steps in order. So the first step in determining, by the way, the question would read, what is or determine the empirical formula? You have to be given a mass ratio or percent by mass ratio. In this case, they're giving us a percent by mass ratio. And so the first one is changed the mass to grams. Poof, it is. In other words, we're going to assume we have a 100-gram sample and 82.63% of 100 is going to be 82.63 grams of carbon. And then we'll do the same thing with the hydrogen. We'll end up with 17.37 grams of hydrogen. If they give us a mass, not the percent, then we're already there. We're going to go from percent to grams, and then the second step, we're going to do a mole conversion from grams to moles. And then the next 2 steps are just steps in reduction. Any kind of math thing would do this. So here we are, we're going to convert the grams to moles. Now these are going to be single elements and not diatomic because they're in compounds, and diatomic doesn't count if you're in compounds. So we're going to have atomic mass on the bottom, 0.01, then go into moles of carbon, and then 1 mole of hydrogen, and 1.01 grams of hydrogen. So when you get the answer for this, you're going to get 6.880 moles of carbon, and you're going to get 17.1, about 17.20 moles of hydrogen. So now we've done that. We have converted the percent to grams, and now we converted the grams to moles. Now the third one says to divide each by the smallest number of moles. So these are going to be whole number ratios, and you want to keep the ratio constant. However, the answer can't be C6.88 H17.20. That doesn't really work. We need whole numbers. So we're going to get these 2 numbers and divide it by the smallest one. Pretty sure that 6 is smaller than 17. So I'm going to get 6.88 and divide it by 6.88 to equal to 1. and this would be mole of carbon, and then we're going to get 17.20 divided by 6.88, and I got 2.499 blah blah blah. In other words, this is going to be 2.5. The last step says if a fraction remains, which means sometimes it doesn't, but I wanted to pick one that does. So in this case, we're going to get, the math will give us 2.5. 2.5, we'll convert that to 2.5. And the last one says if a fraction remains, and it does. By the way, there'll be simple fractions like thirds, quarters, and halves. It says multiply each by the denominator. So in other words, the denominator in the fraction is a 2. I'm going to multiply this by 2 and this by 2. So 1 times 2 is 2. And then 2.5 times 2 is 5. And those are lowest whole number ratios. I got C2H5. Now that we've done the 4 steps to get to the empirical formula, we need to do the 2 steps to get to the molecular formula. Here the formula weight's given. We calculated the empirical formula. We're going to put the formula weight, which is either going to be equal to or bigger than the other one, and we're going to add these up. Carbons are 12 each. There's 2 of them. That's 24. Hydrogens are 1 each. That's 5. Add that up, and the whole thing is 29. So 29 is what the empirical formula weighs, and some pieces like, you know, like 0.7 or something like that. But even if this doesn't end up being a perfect whole number, this answer will always be a whole number, and this one's 2. So this is the empirical formula, and the empirical formula needs to be 2 times bigger to be the molecular formula. So we make this 2 times bigger by multiplying it times 2. So you got C4H10, and that is the molecular formula. It's the actual number of atoms of each element in the compound.